Yeah. It's not going to be less than that.
When you get to negative
And then you guys got 5.9.
Okay, so here is our titration curve for MSG, or glutamic acid. Now, based on the information about the pKa's, can we determine the pHs on this titration curve? So which ones can we determine based on pKa? Yeah, so at the first halfway point, the pH is going to be 2.19. At the second halfway point is going to be 4.25. And at the third halfway point, it's going to be at 9.67. So remember that at the halfway point, the pH equals the pKa. Now, can we determine the pH at the endpoints?
Yes.
Yeah, so at the endpoint, what formula do we want to use? Yes, it's 1/2 pKa 1 plus pKa 2, or it could be pKa 2 plus pKa 3. So at the first endpoint, the pH is equal to 3.22, okay. And then the second endpoint is 6.96, okay. So now we got to figure out the pH at the starting point and then the pH at the third endpoint. And like we said, at the starting point, we want to use Ka. Now, is that going to be Ka1, Ka2, or Ka3? Yes, Ka1. And then at the third endpoint, we want to use which equilibrium constant?
KB3.
Yeah, Kb3. Okay, so I've written on this side of the chalkboard, this is the structure of glutamic acid. So when it loses its first proton, what's going to be the conjugate, the structure of the conjugate base?
It's going to be everything except for the one.
Okay, yeah, so we're going to draw what we have here. Okay, now before we go on, what's the charge? What's the net charge on this structure?
Plus.
Yeah, so the charge is equal to plus, what's the magnitude? Plus 2? So is there a charge of plus 2 on this one? Plus
1.
Yeah, plus 1, because there's only one positive charge, no negative charge, so this thing's plus 1. What's the charge on this structure?
0.
Is 0. So when this substance loses a proton, it's going to form H plus. And what's the structure of the next form of glutamic acid?
The other
Yeah, so George says that this H now, because this is the second strongest acid, so this is going to be lost next. So it's going to form this one. And what's the charge on this form of glutamic acid? Yes, the charge there is going to be minus 1. And then finally, it's going to lose its last proton. So you get H plus, and then the structure in this case is going to be okay, so the charge in this last form is equal to, yeah, minus 2. Okay, so while you're doing these calculations for pH at the starting point, pH at the third endpoint, at the first endpoint, what's going to be the charge on the glutamic acid? Zero. Okay, because note that at the starting point here, the charge is going to be a plus 1. At the first halfway point, what's going to be the charge on the amino acid? Yeah. So half plus 1, half 0. So in other words, at that first halfway point, we're going to have half of this substance and half of that substance present. Then at the first endpoint, we're going to have all of this substance present. At the second halfway point, what's going to be the charge on glutamic acid?
0.
Yes, it'll be 0 and minus 1. At the second endpoint, what's going to be the charge? And minus 1. So at the second endpoint, this is going to be the structure of glutamic acid, this one. Then at the third halfway point, at this point, we're going to have minus 1 and minus 2. And finally, at the third endpoint, this is minus 2 form of the amino acid. So note that you can adjust, you can control the charge of this compound by changing the pH. So as I've said before, in science and engineering and anything else, it's all about control. Control. You can make these things, or you can try to make these things do what you want them to do. And then you'll probably find that it's easier to make chemicals do what you want to do than people. Okay, so anything, what do you have for K, for the pH at the starting point? 1.6? You guys all get that?
Yep.
Okay, so pH here is going to be 1.6. And what about pH at the third endpoint? 11.04. Okay, so should we go over should we go over either this calculation or this calculation? You guys can do it. The pH of the third endpoint? Okay, so let's do that one. So for that one we have KB. We have to figure out KB for this one. Okay, so KB for this one, that's going to be KW divided by KA3. So that's equal to 1 times 10 minus 14 divided by Ka3, so that's equal to 10 to the minus 9.67 power. So when you do that calculation, Kb, we'll call it Kb3. So Kb3 is equal to
4.6768.
So that's going to be 10 to the minus 4.33 power, or
4.68 times 10 to the negative 5.
say that again, George?
4.68 times 10 to the negative 5.
Okay. So then we do our equilibrium calculation. So let's see, we have this one. We'll call this one, well, it's not quite correct to call it A3 minus because the charge is minus 2. So should we call it A2 minus here? Yeah. So for the charge equals minus 2, we'll call it A2 minus. This reacts with water. And that forms HA minus plus OH minus. And therefore, we do our calculation. What's going to be the concentration of A2 minus, that is, this substance at the third endpoint?
0.0251.
Yeah, so we can use 0.025. And this is going to be 0 and 0, so yeah. Okay, so we put in our variables. So now we can plug, so we know that Kb is equal to HA minus times OH minus divided by A2 minus. So let's see, so we're going to have Kb, which is 4.68 times 10 to the minus 5 is equal to x times x divided by 0.025 minus x. And as we've been doing, the x here we're going to say is equal to 0. So if we solve for x, that's equal to 0.0011. So note that this is also equal to OH minus concentration. So now we calculate POH. And then POH is equal to 2.96. And then the pH is equal to 14 minus the POH, which is equal to 14 minus 2.96 or 11.04. Okay, so are you getting to the point where you, once you've done one equilibrium calculation, you've done them all? Oh, so you're not at that point yet? Because I still remember when I was a kid on our family vacation, my youngest brother said to my parents when we were at a national park, well, once you've seen one tree, you've seen them all. That was the last family vacation we took. So that's why I'm asking, once you've seen this calculation, you've seen them all, then you know how to do it.
Actually, when we start off the equation, we get the 10 raised to the negative 9.
Yeah, so this is the, yeah, so remember that if pKa equals minus log of Ka, or Ka is equal to 10 to the minus pKa power. So PK is 9 equals 6, 7, so we're solving for K. So using this formula here.
Where do we pull the 9.6?
That's from here. That's K. Oh. Yeah, because you want to use this one because this one refers to this. In other words, this one goes from this one to that one. So to get to here, you have to use the K from this half. This is K. Okay, so initially we start with here. As you add base, increase the base. Alright, so if you want to add a base, get here. So if I get to here, that comes to this. You have to figure the PK of this axis. And that's the PK of